Today we learn how to simplify radical expressions when adding and subtracting radicals. We'll follow these two basic steps. First, we'll simplify each radical to its simplest form. And secondly, we will combine the like terms. Now if we have 3 groups of root 7 plus 4 groups of root 7, now this works very similarly to algebra, because if I had to say what is 3x plus 4x, we would say, oh, that's easy, 7 groups of x. Now the same rule applies when working with radicals. We have 3 groups of root 7 plus 4 groups of root 7, which is 7 groups of root 7. Our second example. So my first radical is root 8. Now I'll write down my factor pairs. I've got 1 times 8, 2 times 4. Do I see a square number? Yes, I see the square number 4. So I can break root 8 into root 4 root 2. Now my second radical is root 18, so I have to think of factor pairs for 18. Do I see a square number? Yes, again I see my square number 9. So I break it as follows. Now I know that the square root of 4 is 2, and I still have my root 2, and I know the square root of 9 is 3, and I still have my root 2. Like question 1, I have 2 groups of root 2 plus 3 groups of root 2, which is 5 groups of root 2. My third example, let's simplify the radicals. So I have root 45, so let's write down some factor pairs. I see the square number. I see the 9. So again, guys, we have to know our square numbers. So our first step, we have root 9, root 5. Our second radical is simply root 5. We just leave it like that. Root 9 is 3 root 5 minus 1 group of root 5. So we have 3 groups of root 5 minus 1 group of root 5. That is 2 groups of root 5. And there's my answer. So my last question, root 50, let's look at our factor pairs. Any square numbers? Yes, we see our 25. So let's break it up. Secondly, root 18. So factor pairs for 18. Any square numbers? Yes, we see the 9. So we're going to have root 9, root 2. And our last radical, root 8. So factor pairs. Aha, we see our square number again. We see the 4. So we can write. Now we simplify and we have 5 root 2 plus 3 root 2 minus 2 root 2. Now remember, these are groups of root 2. So simply looking at it, I've got 5 groups of root 2 plus 3 groups of root 2. That's 8 groups of root 2 minus 2 groups of root 2. So 8 minus 2 is 6 groups of root 2. You can simply look at the coefficients and simplify nice and quick. Progress check. Have a go yourselves, then check your answers with mine. Root 18, let's do factor pairs for 18. Aha, we see our square number 9. So let's break up that 18. And our root 2 stays the same. Now the square root of 9 is 3. So we have 3 groups of root 2 plus 1 group of root 2. That is 4 groups of root 2. Next up, root 50. Factor pairs for 50. Cool. We see our square number 25. So we have. Now we look at 18 and we write down our factor pairs. Again, we see our square number 9. So we're going to say root 9 root 2. Now, the square root of 25 is 5. Square root of 9 is 3. Now it's a nice simple subtraction. We have 5 groups of root 2 minus 3 groups of root 2. That is 2 groups of root 2. And we're done. Next up, slightly trickier. So we see our root 75. So let's write down some factor pairs for 75. Aha, we see our square number 25. So let's break that up. So we're going to have 2, then root 25 times root 3. Then we have our root 27. So let's do some factor pairs for 27. Aha, our square number 9. So we're going to break it up and have root 9 root 3. And then we have our 4 groups of root 3. 2 times 5, square root of 25 is 5, root 3, minus square root of 9 is 3, root 3, plus 4 groups of root 3. That 2 multiplied by 5 is 10 groups of root 3. Working to the right here. Now I simply look at the coefficients. 10 groups of root 3 minus 3, that is 7, plus 4, that is 11 groups of root 3. And that is my final answer. Last question. So we have root 200. Without writing the factor pairs, I know that 100 goes into 200, and I know that 100 is a square number. So I break that up and I have the following. Now, root 50, you should know that 25 goes into 50, and 25 is a square number. And lastly, root 8, we know 4 goes into 8, so we're going to have root 4, root 2. Square root of 100, 10 groups of root 2, plus 3 multiplied by square root of 25 is 5, root 2, minus 2 multiplied by square root of 4 is 2, root 2. 3 multiplied by 5, that is going to be 15 groups of root 2. Minus 4 groups of root 2. Now we simply look at all the coefficients, and we have 10 groups of root 2 plus 15, that is 25, minus 4, that is 21 groups of root 2. And that is a wrap, guys. So always remember, we simply follow these 2 steps. Simplify each radical to its simplest form, then combine the like terms. And that's it, guys. It's that simple. Have a great day. Hey guys, this is Casey at Onetreemath. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.